So for numbers 1, 2, and 3, you did not need the word because it didn't say to classify. So the degree, if you had cubic trinomial, quadratic binomial, and then quartic polynomial, that would have been correct. So once again, if you had those words, it would have been cubic trinomial, quadratic binomial, and then quartic polynomial. Putting things in order and then identifying the leading coefficient. Make sure you're stealing the sign from in front of each individual term. That's important. And then evaluating, all you have to do to evaluate is to plug in the numbers, right? And then simplify. I think the tricky part is knowing what is like -1 to the third power. That would be -1 times -1 times -1, which is -1. Yeah. So these should be your answers. Remember to include units. And then I'm going to turn the page around. And you guys had odds on the back, correct? So once again, if you used words, this would be a quintic trinomial, a 9th degree polynomial, and then a quintic polynomial. So if you used words there, that's what those would be. For number 5, if you were to rearrange this, the -5h cubed should have came first, and then the 13 needs to go on the back. So your leading coefficient should have been -5. Number 7 was a quartic trinomial. That was tricky because it was not in standard form. So you can see why I wanted you to do some on the back. Oops, sorry, it's hard to see. And then, once again, you need to do some simplifying here. So for number 9, you would have had to distribute the 4. But either way, you should be able to see there'd be 1, 2, 3, 4 terms. Number 11, plugging in -1. -1 to the 7th power is -1. And then the rest of them are kind of doable. But plugging in a negative number multiple times is really tricky. So if you have a question on that, let me know. Otherwise, we're going to get to today's stuff. So like I said, number 13, you're just plugging in stuff. And then it says evaluate for when x is equal 0. It means that they spent $200 to start up their company. Yeah. So if we're adding and subtracting polynomials, the big thing that we need to take note of first is, what do like terms mean? So I want you to see if you can find the like term for 5a. Do you see it? Where is it? 9a. What about for 4xy squared? Do you see it? xy squared. If I were to add 4xy squared and xy squared, what would I get?
4xy is 4.
Wait, hang on. I have 5xy squareds. So the tricky part about like terms, if you're combining them, you're just counting how many of these things do I have, right? If they have the same variables to the same exponents, I'm just counting how many do I have. Well, I have 4 here and 1 there, so that would give me 5. We could continue with this. Usually if it wasn't COVID, we'd play a little game and I'd have 2 people run up and like slap their 2 options and then, but you know, COVID. So anyway, we're going to be talking about, once again, combining like terms today. So a lot of adding and subtracting polynomials is just combining like terms. The tricky part is knowing what those like terms are. And the cool thing is when you add or subtract polynomials, those exponents don't change. So here, I have 12p cubed plus 11p squared plus 8p cubed. These are like terms, so I'm going to combine them to get 20p cubed plus 11p squared, right? Does that make sense? This one doesn't have enough p's. So that's like me saying a second grader and a third grader are the same thing. Does that make sense? and that's why we can't combine them. Oh, they're both going to PW Elementary, right? The P, but they're different grade levels. We can't combine those classes. What about B? Do we have any like terms? I think we do. Do you see them? -6 plus 8. So remember, your answer needs to be written in standard form, so in order by highest degree to lowest. -6 plus 8 is a +2. Yes, question. Right, so this next one, I have a t squared and a -4t squared, which would give me -3t squareds, right? And then I have a 2s squared and a -1s squared, which would give me 1s squared, right? Do you need the 1 in front of the s squared? No, but sometimes it helps just to remind the reader that we still have 1 there. And then this last one. I have m squared n, and m squared n, so technically all 3 of these should be combined, right? So 10 plus 4 is 14, minus 8 gives me, what, 6? Is that right? Okay, good. I was going to say, somebody check my math. It's early in the morning. Do you guys have questions on that? So this is sort of like adding like terms. We have done this stuff before. Tricky part is all those exponents in there. All right, let's move along. So sometimes polynomials are going to be lined up vertically. So in vertical form, you're just going to line up your like terms and then you can add. Or horizontally, you don't necessarily need to like write this down. Basically, they want you to group like terms. So if you're horizontal, you're going to find your like terms, right? And if you're vertical, you got to line up your like terms, right? So either way, it's just a matter of matching things up. So just know that they might line them up one way versus the other, and you just have to make sure that you pick the like terms. Does that make sense? You're just picking the like terms. So yeah, like I said, it's just 2 different ways to do the same thing. But if we have 2 different polynomials that we're adding together, these parentheses really don't matter, right? We're adding like terms. So if we're distributing a +1, this is still going to end up as m squared minus m plus 6. There's nothing on the outside of the parentheses that we have to distribute, right? So really, all I have to do for addition is still the same thing that I was doing before. Where are my like terms at? So I should get a 5m squared. What should come next? What comes next? Good. Nothing goes with that -m, so it's just going to stay -m. And then I can combine my constants, that +5 and +6, to get a +11. Right? This next guy, I see like terms. I see a 10xy and a -3xy. That would give me a 7xy. What comes next? It really doesn't matter what order you put the plus x and the plus y, because they're both degree 1. So you could put the y first if you really wanted to instead of the x. Typically we do alphabetical order once the degree is taken care of, but won't be picky about that. And then this last one. A lot of stuff, right? We have a 6x squared. Do we see any other x squareds? I do. 3x squared and a -8x squared. 6 plus 3 is 9. 9 minus 8 is 1. And then I have my y's. Right? -4 plus 3 minus 2. Whoa. -4 plus 3 is -1. -1 plus -2 is... Good. Why did I choose to do the x squared parts first? Because that was the highest degree. So I always combine like terms based on the highest degree to the lowest. So they are written in standard form. So everything that we've done so far is addition. We do have to worry about subtraction, but there's really only one more additional step. If we're going to subtract, really all we're going to have to do is distribute that negative into the parentheses and then do our problem. So we're going to have x cubed plus 4y minus 2x cubed. And now that we've distributed that subtraction sign, we can just combine like terms, right? We have an x cubed and a negative 2x cubed, which gives me negative 1x cubed. And then that 4y is still by itself. The reason I have to distribute is if I'm subtracting this entire thing, it's going to change the sign of all three of these items in the parentheses, right? So I'm going to get 7m to the fourth minus 2m. That doesn't change, but everything after the subtraction sign is going to switch signs. And then, do I have any like terms? I think we do. Which ones? The 7m to the fourth and negative 5m to the fourth. Well, that would give me a 2m to the fourth. My next highest degree is 5m squared, but it doesn't look like anything goes with that, right? What about the negative 2m? They have a different amount of m's, so that's like a first grader and a second grader being in the same classroom, right? Oh, it is a 2m squared. Ooh, I just wrote the question down wrong. So if we have 5m squared and 2m squared, negative 2m squared, what should we get? 3m squared. Thank you for pointing that out. I was really confused. I was like, no, 2m and yeah. And then the minus 8's all by itself. Thank you for pointing that out. I owe you a Jolly Rancher. All right. Do you guys feel like you get the point? You distribute the negative, you combine like terms? Okay, you guys can start your homework.